Statistics. Going to talk about counting. One needs to be able to count things. And prior to really getting into counting, there's some notation. Whenever you see that symbol, that means n. In words, it means n factorial, or it's read as n factorial. Well, what does it mean? N factorial is 1 times 2 times 3, all the way up to times n. The 3 dots means and so on. That is 3 factorial. Another way of saying it is whatever n is, you start with n and you multiply all the way down to 1. You start at 3, you go 1 less, you go 1 less than 2, and when you get to 1, you stop. 3 times 2 times 1 is 6. 4 factorial. You started this number and you go down to 1. And you keep going down by 1. 4 minus 1 is 3. 3 minus 1 is 2. 1 less than 2 is 1. 12 times 2, 24. 5 factorial is 5 times 4 times 3 times 2 times 1. Now, we don't have to keep inventing the wheel. We know what this is. It was right here. We know what it is. So it's 5 times this, which is 25 times 24, or 120. If that wasn't in front of you, how I would do it is 5 times 4 is a nice number like 20. This is a simple number like 6. 20 times 6, 120. 1 factorial is just 1. By definition, 0 factorial is 1. There's no way to understand that. Okay? There's no way to understand that. It's just by definition. For example, the definition of n factorial. A lot more erased than I wanted, but not a big deal. A lot more. Okay, so the definition of n factorial is the following. N factorial equals that provided that n is an integer bigger than 1. The comma means provided that. Provided that n is a positive integer bigger than or equal to 1. Oh, sorry. Goes after the equal sign. And this is equal to 1 if n is 0. That is, 0 factorial is 1. If this number is 0, then you get 1. If this number is 1 or more, then you get this. It's the definition. 0 factorial is 1. Now let's do a counting problem. The number of ways to arrange n objects in a line is n factorial. The number of ways to arrange n objects in a line is n factorial. For example, what if n was 3? What if n is 3? If n was 3, then I claim the number of ways of arranging these 3 objects is 3 factorial. The 3 objects were A, B, and C. 3 people, Abe, Betty, and Carlos. How can you arrange Abe, Betty? How many different ways can you arrange Abe, Betty, and Carlos in a line? Well, if n is 3, I'm claiming it's going to be 3 factorial, which is 3 times 2 times 1, 6 ways. And here they are. A, B, C. The first letter I write, that's the first position. The second, the third. A, B, C. Keeping A first, I could switch B and C. Those are the only 2 ways that A can be first. Now, what if B is first? Well, then you can have A and C next, or you can have C and then A. Those are the only 2 ways of arranging A, Betty, and Carlos where Betty is first. Now, what if Carlos wants to be first? He doesn't want to keep being second or third. You can have CAB, or you can have CBA. So yeah, this formula is working. The number of ways of lining up 20 different people is 20 factorial. There are different ways of arranging 20 different people. There are a number of ways of arranging 3 people. And the number in a line. The number of ways is 6.